Hello friends, this is Manoj Manda. Today I am going to discuss about a topic that is frequency division multiplexing. So in this presentation we are going to discuss about frequency division multiplexing in details. So let us start. So these are my contents. What is multiplexing? Categories of multiplexing. What is frequency division multiplexing? Frequency division multiplexing process. Applications of frequency division multiplexing. Advantages and its disadvantages. At first, we are know about what is multiplexing. Multiplexing is a process of combining multiple signals into a one signal and over a shared medium. If analog signals are multiplexed, then it is called analog multiplexing, and if digital signals are multiplexed, that is called or digital multiplexing. The purpose of multiplexing is to enable signals to be transmitted more efficiently over the given common transmission channel, thereby decreasing transmission cost. A device called multiplexer combines the inputs into one composite signal. Multiplexing is done by multiplexer. Demultiplexing is done by demultiplexer. Multiplexer receives large number of different input signal. Multiplexer combines all the input signal into one composite signal, then transfer it. Multiplexing can increase the amount of transmitting information efficiently. It is efficiency of the utilizing bandwidth can be achieved through multiplexing. Example: radio transmission multiplexing. Here is the block diagram of multiplexing. There is a multiplexer and a demultiplexer. It is called the transmitting side. This is called the receiving side. This is transmission channel. The signal 1, signal 2, signal 3 is multiplexed by multiplexer, and the composite signal transmitted through the transmission channel. And in the receiver side, by using a demultiplexer, we demultiplex the signals, and receiver receives the signal. Multiplexing is achieved using multiplexer combines an input line to generate a single output line. Multiplexing follows many to one, n input lines and one output line. Demultiplexing is achieved by a device called demultiplexer available at the receiving end. Band range of frequency is called band. Guard band unused bandwidth between two bands is called guard band. Categories of multiplexing. Multiplexing is divided in some categories. Multiplexing is divided in three major categories: frequency division multiplexing, time division multiplexing, and wavelength division multiplexing. Furthermore, the time division multiplexing is divided into two types: synchronous time division multiplexing and statistical time division multiplexing. Frequency division multiplexing. Each signal is assigned a different frequency in frequency division multiplexing. In time division multiplexing, each signal is assigned a fixed time slots in the fixed rotation. Wavelength division multiplexing, each signal is assigned a particular wavelength, and wavelength in in the ch- in the channel used in it is used in optical fiber. Frequency division multiplexing. Frequency division multiplexing is the technique of multiplexing which means combining more than one signal over a shared medium. In frequency division multiplexing, signals of different frequencies are combined for concurrent transmission. In the frequency division multiplexing, multiple signals are combined for transmission on a single communication line, which with each signal assigned to a different frequency within the main channel. Here is the block diagram of the frequency division and multiplexing. This is called the transmitter side. This is called the receiver side. This is the transmission channel. The is, transmitting signal is combined by a multiplexer, and it is demultiplexed by a demultiplexer in the at the receiving side. Multiplexing process. Each source generates a signal of similar frequency. Inside the multiplexer, these similar signals modulated by different carrier frequencies, F1, F2, and F3. The resulting modulated signals are then combined into a single composite signal that is sent over a media link that has enough bandwidth to accommodate it. The given figure is conceptual illustration of the multiplexing process. Here, the three sources are generates the three similar range frequencies by the modulator. Modulator the each frequency each transmitting each transmitted frequency is modulated by a respective carrier frequency. Like first signal is modulated by frequency F1, second signal is modulated by carrier frequency F2, and third signal is modulated by carrier frequency F3. Then by using a multiplexer will multiplex the three frequencies into a composite frequency that is transmitted through the channel. The demultiplexing process. The demultiplexer uses a series of filters to separate the multiplex signal into its constitute component signals. The individual signals are then passed to a demodulator that separates them from their carriers and pass them to the output lines. Given figure is the conceptual illustration of demultiplexing process. Here the composite signal is coming through the transmission channel. By using demultiplexer, we demultiplex the frequencies, and by using band pass filter, we select some frequencies, and then we use the same carrier frequency what we have assigned into the in the transmitting side. At the carrier, the fast signal is demodulated using the carrier's frequency F1, the second signal is F2, and the third signal is F3. And then the signals is going through a low pass filter, and we gets the original signal at the receiver end. This is how the demultiplexing process works. Applications of FDM. Frequency division multiplexing is several uses: radio transmissions and commercial AM and FM, TV transmissions, wireless networks, satellite communication, and the fast phones like cellular or mobile phones. Voice signals between 3 kilohertz. From voice signals, the bandwidth from 300 to 3000 kilohertz. Advantages of FDN. A large number of signals can be transmitted simultaneously. Frequency division multiplexing does not need synchronization between its transmitter and receiver for proper operation. Demodulation of FDM is easy due to slow narrow band fading. Only a single channel gets affected, less expensive. Disadvantage of FDM: the communication channel must have a very large bandwidth. Intermodulation distortion takes place. Large number of modulators and filters are required. FDM suffers from the problem of crosstalk. All the frequency division multiplexing channels gets affected due to wideband fading. Thank you.